Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on analytical dynamics or classical mechanics, chapter Equations of Hamilton, lecture number 1, in which I will derive the Hamilton's canonical equation. Now we solve the question. Define the Hamiltonian for a conservative holonomic dynamical system. Derive Hamilton's canonical equations of motion from Lagrange's equation. Now we solve this. Let us consider a conservative holonomic dynamical system. Since the system is conservative, therefore forces are derivable from potential function, and potential function is a function of position coordinates only, not that of velocities. Now let constraints are independent of time, therefore position vectors will be the function of generalized coordinates and do not involve the time t explicitly. That is, position vector r mu will be the function of q1, q2, qn. Let this is number 1. Hence, Lagrangian function L will be the function of qi dot I equal to 1, 2, n. That is, L is the function of qi position coordinates and qi dot. We may write this as L is the function of q1, q2, qn and q1 dot, q2 dot, comma qn dot. Differentiating with respect to t, we get partial derivative of L with respect to q1 dq1 by dt plus partial derivative of L with respect to q2 dq2 by dt plus plus partial derivative of L with respect to qn dqn by dt plus partial derivative of L with respect to q1 dot dq1 dot by dt plus partial derivative of L with respect to q2 dot dq2 dot by dt plus plus partial derivative of L with respect to qn dot dqn dot by dt. We may write this as sigma I equal to 1 to n partial derivative of L with respect to qi. Here 1, 1, here 2, 2, here n, n. So we take the sigma I equal to 1 to n dqi by dt plus here also 1, 1, 2, 2, n, n. We take another sigma I equal to 1 to n partial derivative of L with respect to qi dqi dot by dt. Let this is number 2, this is number 3, this is qi dot. Since Lagrange's equation of motion B d by dt partial derivative of L with respect to qi dot minus partial derivative of L with respect to qi equal to 0 implies that partial derivative of L with respect to qi equal to d by dt partial derivative of L with respect to qi dot I equal to 1, 2, dot, 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 n. Let this is number 4. Using 4 in theory, we get dl by dt equal to sigma. We may write here only I. If we write only I, this will denotes I equal to 1 to n. Here partial derivative of L with respect to qi. This means d by dt partial derivative of L with respect to qi dot and dqi by dt is qi dot plus sigma I partial derivative of L with respect to qi dot. Here q dqi by dt is qi double dot. We may take these as single sigma I d by dt partial derivative of L with respect to qi dot plus partial derivative of L with respect to qi dot qi double dot. We may write this I d by dt partial derivative of L with respect to qi dot and here qi dot. This means d by dt right side. Firstly we are writing right side sigma I partial derivative of L with respect to qi dot minus d by dt. Here L we write this. We take this that side and we have written both terms in left side. This equal to 0 and this will be equal to d by dt. We write minus L d by dt we have taken here, minus L plus sigma I, partial derivative of L with respect to qi dot equal to 0. Let this is number 5. Since L equal to t minus v and v be the function of q1, q2, qn, position coordinates, means here generalized coordinates. Therefore, partial derivative of v with respect to qi dot will be 0. Since v is not the function of velocity, qi dot is the velocity. So this is 0. This is number 6. This is number 7. Now, partial derivative of L with respect to qi dot equal to partial derivative with respect to qi dot, L means t minus v. This equal to partial derivative of t with respect to qi dot minus partial derivative of v with respect to qi dot. This equal to partial derivative of t with respect to qi dot, and this is 0 from 7. Using 7, and this equal to partial derivative of t with respect to qi dot, and this equal to pi, where pi be the generalized component of momentum. This is number 8. Using 8 in 5, we get d by dt minus L plus sigma I. Value of this is pi from 8, pi qi dot equal to 0. Integrating, we get minus L plus sigma I pi qi dot equal to a constant h. This is 9. H equal to minus L plus sigma I pi qi dot is a constant of motion with condition that L does not involve the time t explicitly. This constant h is called Hamiltonian. Since from 8 we have pi equal to partial derivative of L with respect to qi dot, implies that dpi by dt equal to d by dt partial derivative of L with respect to qi dot, and this will be equal to partial derivative of L with respect to qi using 4. implies that this is pi dot derivative with respect to t, this equal to partial derivative of L with respect to qi. Let this is number 10. If L contains time t explicitly, then L will be the function of generalized coordinate qi dot velocity and time t. We may write this as L is the function of q1 q2 dot qn q1 dot q2 dot qn dot and t, implies that dl equal to partial derivative of L with respect to q1 dq1 plus partial derivative of L with respect to q2 dq2 plus partial derivative of L with respect to qn dqn plus partial derivative of L with respect to q1 dot dq1 dot plus partial derivative of L with respect to q2 dot dq2 dot plus partial derivative of L with respect to qn dot dqn dot plus partial derivative of L with respect to t dt. This equal to, up to this we may use a sigma I partial derivative of L with respect to qi dqi. From this to this we use another sigma I partial derivative of L with respect to qi dqi dot, and this partial derivative of L with respect to t dt, here a dot, this equal to sigma I, this partial derivative of L with respect to qi, this is pi dot using 10, and this is dqi sigma I, this is pi using 8 dqi dot plus partial derivative of L with respect to t dt using 10 and 8. Here we have used 10 and here we have used 8. Let this is number 11. Now d pi qi dot, this equal to pi dqi dot plus qi dot dpi, implies that dpi qi dot minus qi dot dpi equal to pi qi dot. Let this is 12 using 12 in 11 we get here left side dl sigma I pi dot dqi plus sigma I. For this we write left side of 12 d pi qi dot minus qi dot dpi, and here partial derivative of L with respect to t dt. This equal to sigma I pi dot dqi plus sigma I d pi qi dot minus sigma I qi dot dpi plus partial derivative of L with respect to t dt. We write this term and this term right side and remaining term left side, implies that sigma I pi dot dqi, this left side means negative here and this left side means positive here, sigma I qi dot dpi, and this positive term left side negative minus partial derivative of L with respect to t dt equal to this term right side minus dl, and this remains in right side plus sigma I d pi qi dot, and this will be equal to minus dl plus, we may take d outside, d sigma I pi qi dot. We may write this d minus L plus sigma I pi qi dot using 9. This is h, the term under bracket is h, using 9 implies that dh equal to minus sigma I pi dot dqi plus sigma I qi dot dpi minus partial derivative of L with respect to t dt. This is number 13. Since we have seen in 9, since from 9 h is the function of qi, pi and t, implies that h is the function of q1, q2 dot 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 qn, p1, p2 dot 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 pn and t. implies that dh equal to partial derivative of h with respect to q1 dq1, partial derivative of h with respect to q2 dq2, plus dot 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 partial derivative of h with respect to qn dqn, plus partial derivative of h with respect to p1 dp1, partial derivative of h with respect to p2 dp2, plus dot 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 partial derivative of h with respect to pn dpn, plus partial derivative of h with respect to t dt, and this will be equal to sigma from this to this I partial derivative of h with respect to qi dqi. From this to this we may write sigma I partial derivative of h with respect to pi dpi, plus only this term partial derivative of h with respect to t dt. Let this is number 14. Comparing 13 and 14, we get here coefficient of dqi is pi dot. Here coefficient of dqi is partial derivative of h with respect to qi. Therefore, partial derivative of h with respect to qi equal to minus pi dot. Here dpi, here dpi. So coefficient here partial derivative of h with respect to pi, partial derivative of h with respect to pi, and this is qi dot, and next is coefficient of dt, partial derivative of h with respect to t equal to minus partial derivative of L with respect to t, I equal to 1 2 dot 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 n. Equation number 15. We rewrite equation 15 as follow: qi dot equal to partial derivative of h with respect to pi, pi dot equal to minus partial derivative of h with respect to qi, and partial derivative of L with respect to t equal to minus partial derivative of h with respect to t. Here I equal to 1 2 dot 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 n. These equations are called Hamilton's canonical equation of motion. So we get the Hamilton's canonical equations of motion. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.